Hello everyone and welcome to our channel again. Today I am going to discuss one of the most popular ML algorithm, that is random forest. In my last session I already discussed the decision tree, and today I will discuss why we need random forest, because random forest also actually combination of multiple decision trees. So why need random forest when we already have a decision tree? And I will try to explain this very simply so that beginners can understand clearly. Let's have a look. So I'm going to start with a simple scenario. Imagine you want to predict whether a customer will buy a laptop, or suppose you want to buy a laptop. What you will do? Definitely, you will ask some one expert, right? One or more expert in real life. So basically, who have more knowledge on laptops. So suppose he say yes, you can. So if you only ask the one person, so you cannot completely trust on one person, right? But instead, if you ask the 10 people, and um, from the 10 expert or person, you got the answer like 7 yes and 3 no. So definitely you can just you will have confidence that yes, as yes is most people says yes, so you can buy, you will buy the laptop, right? So random forest works actually exactly like this. Instead of trusting one decision tree, it creates many decision trees and combines their predictions and choose the most uh, most voted result. Okay. Next, let me just tell me. I'll tell you the formal definition of the random forest. So random forest is an ensemble machine learning algorithm that builds multiple decision trees using different random datasets and combines their prediction to make a more accurate and stable prediction. So in random forest, what is done? Actually, it creates a different decision trees and train those decision trees with the multiple dataset. Sorry, different combination of dataset, not the same dataset. So that every decision tree will train with different dataset, and with not only the dataset, also with the different features, random features. Okay, so let me just split the random forest into two parts: the random and forest. When you first understand what is random, what is forest, then its name actually suggests what is the functionality of random forest. Random means, so every tree gets different training data and different features randomly. That's why it is called random. And why it's forest? Uh, as in natural forest, in nature forest contains many trees, right? So here, same here, as the this algorithm creates many trees, decision trees. So that's why it's called forest. Hope you understand why random and forest. Why this ML algorithm called random forest. So let me discuss why do we need a random forest. Just try to tell you in more details. Okay, suppose you only have one decision tree, right? In terms from the training data, sometimes it's learned too much, even the unnecessary details. This is called the overfitting. So overfitting is the major issue of the decision tree. So for in the right side, you can see suppose this is a training data set. Okay, so age is 20. So by laptop no, 25 no, 30 yes, 35 yes. Okay. For the data, suppose recently learns this data perfectly and this was a training accuracy 100%. Now, if we add a new customer, age is 28, in that case, uh, our decision tree may fail because it memorized the data, training data, instead of learning the general pattern. But random forest reduces this problem by combining the prediction from many trees. Not just depend on the one decision tree. This is a very high level explanation. Okay. So, so what are actually the decision tree problem? It's overfitting as I told. Another is the high variance. What is high variance? Suppose data set has 100 customers. Okay, you remove just one customer. Decision tree may choose a completely different fast split. For example, for dataset one, you split a dataset based on the 50K income. But if the new dataset come in a new dataset, you have recently may split dataset based on the 30. So every teeny change in the data can produce a very different trees. So this instability is called a high variance. Let me show you the high variance in more details so that you can understand. Just let me open the document. Okay. So you can see my screen, the data set. Okay. Age is 25, 25, 30, 30, 45. Okay. And decently creates age 27. Okay. It's a sweet point. I'm not showing you the actual calculation. Uh, Now if we remove the one row, like say we remove 30, the 30th color row. Okay. This row remove. So now the base tree becomes a S30. That means the entire tree changes, right? I cannot. I'll not explain here the what is a split. If you already seen my the previous recently tutorial, you may know the what is the split point, right? Actually, in one line I can say it split the data set until pure group is created. Okay, so just one row change, the entire tree change. So this is the problem of a decision tree. This is called also high variance. You can think suppose think of two students. Student A changes his opinion every day. Monday say I love Python. Tuesday say I hate Python. Wednesday say I love Java. So you can say the student A is very unstable. They do not stick to any particular decision. So decision tree based similarity. A teeny change in the data can create completely different trees. I hope you understood. Now, next problem is the one opinion. That means in a decision tree there is only there is only one decision tree, so we have to decide the predict the answer only based on the one opinion. But in here random forest uh, predict the answer based on the many opinion, as it creates a different uh, multiple decision trees. Okay, so obviously um, if you get answer get opinion from multiple people in real life, obviously you will get the better solution than only depend on only single people, right? Now, how random forest works? Just I just explain it very high level. Suppose your data set on data set is this 10 customer, like 1 to 10. So first is first thing next thing what it will do is as per this algorithm, random forest algorithm, it creates a multiple data set by randomly selecting rows with replacement. What is replacement? So what does replacement mean? So imagine picking a ball, recording it and putting it back. Suppose it creates a one data set like this. Notice that here 7 and 7 appears multiple times, 1, 2 and 3, and 8 missing. Why? Actually, let me explain you. Whenever is going to choose random number from here, suppose first is pick one, any random value, for say 7, and I can explain with the example of ball. Suppose there is a basket of ball, okay, numbers with 1 to 10, and it picked the first ball randomly, just the ball was 7, and it put in a new basket 7, but the same number it back to the data set. I mean, added at the back of the data set. And then that means it peaked, but it actually not deleting this basket. Instead, it added this peak number in the same basket. So all number remain present in the basket. That means if 7 peak, we are not deleting the 7 from here. Still 7 is present in the basket. So next time when we are going to pick next number, it may choose 7 again, because 7 present was there also, but not deleting this number. That's why it is with replacement. It replaces the same number with the same number. So that means I want to mean that if pick the same 7 from the bucket, it also replaces the 7 with the same 7 number. So that's why multiple number repeat same number multiple time present in the new data set as it is picking randomly. So this way it will create the multiple data set. Actually based on the how many data set you will create, based on the how many trees we're going to create in within the random forest. Okay. So this is called the bootstrap sampling. This process is called bootstrap sampling. Next is step 3. So build the multiple decision trees. As I said, in this next second step, just I explain how number things happens. Now is the multiple in the same way. It creates a multiple decision tree based on how many decision tree you're going to. Sorry, uh, it will create a multiple decision tree and as well as a multiple data set for the each trees. Same logic. Okay. So that means same data is not going to use by the multiple data set and addition tree. So every addition tree will get the distinct set of data. Next next step is the random features. So so every addition tree get the different data set and also it will pick the random features as well. Suppose our data set has like features like these features like age, salary, city, gender, result, education, credit score. And normal dictionary actually consider all the 6 at once. But in case of random forest, to introduce the randomness, we here use like logic like T1 may use age, salary, city, and T2 may use gender, education, credit score. T3 may use salary, age, like that. So randomly features are selected for every trees. Now step 5. So now each tree makes a prediction. For example, T1 gives yes, T2 gives no, T3 yes, T4 yes, 5 no. Now combine the prediction. So so yes, 3 yes vote given by 3 random decision trees, no voted 2 decision trees. So fine, that means as the yes voted vote number is highest, that's why final prediction is obviously yes. So this is for the classification. And for regression type of model, actually, I just missed one thing. Random forest actually, there are two type of algorithm, type of algorithm. One algorithm is for classification model, and another for regression. The classification for only yes or no, and regression is a continuous number. Okay. So suppose we are predicting the price of the house. So each tree predicts the price like this. Then it will take the average and final prediction is the average of the uh, all the decision trees output. So this is the actual high level overview of the how is random forest works internally. So finally, why decision tree random forest give better result? So as I said, each tree learn from different data set. Each tree is considered different features. So errors made by one tree are often corrected by the another trees. So combining many prediction reduces the chance of making a wrong decision. Obviously. So this is a similar to asking many experts instead of the relying on one opinion. That's why random forest gives a better result compared to decision tree. Advantage: high prediction accuracy, reduce the overfitting compared to single decision tree, handle both classification and regression, works well with large data set and can estimate features important, more stable than single decision tree. And disadvantages: definitely every model has advantages as well as disadvantages. Slower to train one decision tree than one definitely because there are multiple decision trees. So multiple trees need to be trained. Record more memory obviously. Harder to interpret because it contains many trees. Large forecast forest can increase the prediction time. And hyperparameter is like n estimator, number of decision trees in the forest more usually improve stability but increase the training time. Max depth, maximum depth of the trees, limited depth cancels overfitting, max features, okay, number of features randomly considered at each split, minimum sample split, okay, minimum sample leaf, bootstrap, random state. So in this video, I'm not going to explain these features. Okay, in next lecture, I will give the code example and also explain these features, hyperparameters. Okay. So in real world, the application of the random part like loan approval prediction, credit risk assessment, fraud detection, disease diagnosis, customer chunk prediction, house price prediction, email spam prediction, employee attrition prediction, product recommendation, and many more. So decision tree mean one tree and random forest many trees. Decision tree mean one opinion and for many opinions. Here more prone to overfitting, less prone to overfitting, high variance, low variance, faster, slightly slower, easier to interpret, harder to interpret, low stability, higher stability. So key takeaways: random forest is a collection of many decision trees. Bootstrap sampling creates different training data set. Random feature selection makes each tree learn differently. Classification use majority voting. Regression use the average prediction. And combining many trees makes the model more accurate, stable, and resistant to overfitting than a single decision tree. So that's all for today.